All right. Hello to everyone. This is Shubham. In this video, we'll be talking about the pre-calculus, basics of pre-cal. Okay. So to begin with, let's start with the first topic, that is functions. So in functions, we'll be talking about, how to draw the functions, how to factorize them, and then inequalities related to factors. Okay. So let me put the first question over here. Let's suppose we have f of x equal to, let's say x squared plus 5x plus 6. All right. Now, there are certain questions over here. Let's say part A, I have to find when f of x is equal to 0. Part B, when f of x is greater than 0. And part C, when f of x is less than 0. Are you getting it? So here we have three things, right? Now, in order to answer when f of x is 0, we have two methods. Either I factorize this, okay, by splitting the middle term, or I'll do completing the square method. So now I know that two numbers whose sum is 5, right? And product is 6. What is that? 3 and 2. So I can simply write it as x plus 2 times x plus 3 equal to 0. Okay. And therefore, when I find the zeros, I get x equal to -2 or x equal to -3. So the answer to the first bit, when my f of x is equal to 0, either you can use splitting the middle term or you can use completing the square method. Okay. If you are allowed to use calculator, then well and good. All right. Now, the next thing is we have to find the value of x for which my whole function is greater than 0. That means for what range of x my function is positive. Are you getting it? Okay. So now what we do over here is draw a number line. Okay. So on a number line, where does -2 and 3 lie? Okay. So I know that here is -2 and here is -3. So we plot the roots on the number line as they occur on a number line, right? -2 first, and then on the left-hand side, -3. Now, take any value of x, right, which is actually greater than -2, and then check the sign of these two factors. Are you getting it? So now, before we move on to, drawing the inequality over here, let's understand what kind of equation is this. It's a quadratic equation, right? Because the degree is 2. Now, it's a quadratic equation, and we know that the graph of any quadratic equation is called as a parabola. Yes or no? Yes. So what kind of parabola will we get? We'll get a parabola which is opening upwards. Yes or no? And that is decided by what? That is actually decided by the coefficient of x. Okay. So here it is +1. So I know that when a is greater than 0, it will open upwards. And if a is less than 0, it will open downwards. Yes or no? Yes. Okay. So we have two parabolas which opens upward and downwards depending upon the leading coefficient. What is this a called as? A is called as the leading coefficient. What do we mean by leading coefficient? Leading coefficient is nothing but the coefficient of the leading term. Okay, so if it is positive, the parabola will open upwards. Now we have to answer over here. Okay, now randomly if I take any number, let's say -1. Okay, if I plug in -1 over here, what will be the sign of x plus 2 and x plus 3? X plus 2 will be positive, isn't it? When I plug in x equal to -1. -1 plus 2 is +1, and this is also positive, right? +2. So this is always greater than 0. So here it is positive, isn't it? And we also know that this -3 and -2 are the roots. If they are the roots, that means one thing is true, that my graph will cross this line. Yes or no? Yes. So it will go upwards. And how do I know it will go upwards? Because of the leading coefficient, isn't it? Similarly, I can take -4. If I take x equal to -4, what is this term x plus 2? Isn't this negative? Because -4 plus 2 is -2. And then you have x plus 3, which is also negative, right? So negative times negative is what? Positive. So my graph is above the x-axis. Basically, this is what? X-axis, isn't it? Now, So how do I write this final answer in terms of, you know, inequalities, right? So we should know how to write them in terms of inequality as well, right? So they have asked when my graph is f of x, right? My function is greater than 0. So when is it greater than 0? So I'm writing it down over here. When x is less than -3 or when x is greater than -2. Yes or no? So the same thing, right? We can also write in terms of union, right? So x belongs to, in terms of interval, basically it is called as. So less than -3. So minus infinity, -3, union, -2 to positive infinity. And then these are called as open brackets, where -2 and -3 are not inclusive. Okay. Yes. So this is inequality and this is writing final answer in terms of your interval. Okay. This is basically your interval form. So we should know both ways, right? So I hope this concept is clear to you. Now, next, moving on to the C part, which says f of x is less than 0. When f of x is less than 0, come to this again. Isn't the function below the x-axis in between -3 and -2? Isn't it? So how do I write my answer? X greater than -3 and less than -2. Are you getting it? So how do I write in terms of interval? X belongs to square brackets -3 and -2. Okay. Always the smallest on the left hand side and the bigger number on the right hand side. Is it clear? Right? Perfect. Now let's move on to the next question. Okay. Was it equal to? Okay, let's make this as equal to, because we had done one without equal to, right? So if it is equal to, then we have to use square brackets, because one we had already done because it is greater than, strictly, right? Strictly greater than 0. So we have done what with strictly greater than, and one with equal to and less than. Okay. If let's suppose if I take another one d, f of x is just less than 0, then in that case, x will belong to open brackets -3 and -2. This means what? -3 and -2 are not included. Getting it? So this is an open interval. All right. Now, moving on to the next question. Let's suppose if I give you any function g of x, which is something sort of x squared plus 4 plus 4. Okay. And then again, there are two parts. One is g of x equal to 0. And then the second part, g of x is greater than 0. And then the c part, g of x is less than 0. Okay, we need to solve this. All right. So now, what is the first thing? In order to prove equal to 0, either you factorize it. Okay. So clearly I can say that this is x plus 2 whole square. Yes or no? Okay. Now, how do you solve this using splitting the middle term? Two numbers whose sum is 4 and product is 4. Right. So that is nothing but x plus 2 times x plus 2. Yes or no? That's the reason we have written x plus 2 whole square. This is what is written over here. Okay, now when I equate this x plus 2 whole square equal to 0, what do I get? I get x equal to -10. Are you getting it? So what's the answer for the first bit? X is equal to -2. Right. Now, what do you mean by x equal to -2? This is the root, isn't it? This is the root. So how the graph will look like? So it will look something sort of this. Here we have -2. Okay, and it's a parabola opening upwards because the coefficient of x is +1, right? So it's a parabola opening upwards. All right. Now see here, we are getting only one root, but this is a quadratic. So we should get two roots, no? So here we have repeated roots, -2 and -2. Okay. So -2 and -2 both are clubbed together because they are one and the same thing. So we get a parabola opening upwards. Okay. And it touches the x-axis only once, right? So this is basically what? A repeated root. -2 is called as the repeated root. Yes or no? Now, second bit is g of x is greater than 0. So greater than 0 means what? For what values of x, my function is positive, isn't it? So except at -2, at -2 it is 0, except at -2, except -2, my function is always positive, isn't it? It is above the x-axis. So it is always positive except at -2. So what will be my x? X belongs to all real numbers minus this -2. And this is how we write in curly brackets because I have to remove this -2. Are you getting it? Right? Okay. Now, answering the third bit, which is g of x is less than 0. So do we have any value of x for which my function is below x-axis? No. So no values of x. The function is negative, isn't it? So it is never negative. You can write like this also. Yes or no? Right? Okay, perfect. Now, understand two things. Important learning. When we have repeated roots over here, right? This is the graph. So when this is the graph, we have repeated roots. Whenever you have a plus b something whole square, you get a repeated square, right? So repeated roots, that means what? The graph, it touches at that root and then it goes up, isn't it? That means whenever we have a repeated root, my graph is not crossing the x-axis. Yes or no? So before that also it was positive, and after that root also it is positive, the value of the function, whenever it is repeated roots. Yes or no? And when I see it before, see here, -2 and -3. What are these? These are odd roots. Okay, because the corresponding factors to them are what? X plus 2 and x plus 3. Right? So -2 is the root. So the factor corresponding to -3 is what? X plus 3. And the factor corresponding to -2 is how much? X plus 2. Right? So when I say odd factors, right? X plus 3 to the power 1, x plus 2 to the power 1, right? This thing is equal to 0. That means what? Whenever you have the odd powered roots, or you can say the factors, right? And the roots corresponding to odd powered factors will be such that on the right hand side, if the function is positive, right? Then here it will be negative. There will be an alternate sign change for the function, right? So as you can see clearly here, -2 is an odd root, isn't it? What do I mean by odd root? The root is not odd. The factor corresponding to that root is odd because the power is 1. And here also x plus 3 to the power 1. Are you getting it? Right. So now I hope this thing is clear. Let me take one example, then it will be more clear to you. Okay. Let me put it here. Next question. Let's say we have x minus 3 to the power 4, x plus 5 to the power 7 multiplied by 3x minus 11 to the power 4 is less than equal to 0. Okay. Now, how do we solve these type of questions? So, step 1, always remember, find the roots. Okay. How do I find the roots? Equate all the individual factors to 0. Okay. So, from the first one, what do we get? From here, we get x equal to 3. From here, x equal to -5. Right. And from here, 11 over 3. Got it? Now, what is the next thing? Step 2. Plot them on the number line. Where do we plot it? On the number line. Here. So here we have -5, and then we have 3, and then we have 11 over 3. Obviously, 11 over 3 is greater than 3, right? So this is my number line, right? Okay. Now, we have to check for what interval of x my function is negative. Okay. So we will use this concept, what we have learned just now. Okay. Now, all you have to do is below these roots, right? Below these roots, you just write they belong to which factor. That means they belong to odd factor or even factor. 3 is a root from which factor? Even, right? X minus 3 to the power 4. So this belongs to even factor. Okay. -5 belongs to odd factor because 7 is an odd number. Yes or no? 11 by 3 also belongs to even factor. Are you getting it? Now, all I need to do is just take a random point, basically a number which is greater than 11 by 3. You can take any number between any of these things, right? You'll get the same thing. If I take any number, let's say, for example, over here, between -5 and 3. So let's say if I take 0, okay, or let's take 1, any number here, 1. Let x equal to 1. Now, when x is equal to 1, what happens to x minus 3? 1 minus 3 to the power 4 then you have 1 plus 5 to the power 7, then you have 3 minus 11 to the power 4, right? Negative number to even power is positive. This is already positive. And 3 minus 11. So minus 8 to the power positive 4, right? So this is also positive. Yes or no? So positive times positive times positive is what is always positive. That means my graph over here is positive. Okay, that's all. Now what you have to do is, once you know my function is positive, okay, between minus 5 and 3, right? Now, see, I've taken just x equal to 1. You can take any number between minus 5 and 3, it will always be positive. We'll come to this. Okay, why is it so? See, what is minus 5, 3, and 11 by 3? These are roots. What are these? These are basically our roots, isn't it? 3 minus 5, 11 by 3 are the roots. And we know that. How do we get these roots? Right? Either my function is, going like this. This is my even powered root. And when do we get roots? Let's suppose if the function is something like this, right? So here it crosses x-axis, and then it crosses x-axis, and then it crosses x-axis. Are you getting it? So the second root, first root is minus 5. Let's suppose I'm just taking an example like this, and I know for the fact that 3 is the second root. So it has to cross, right? It has to cross the x-axis. Then only you get the roots. Roots means values of x for which the function is 0. Okay, so that means my graph has to cross this, something like this and this. We'll see. Okay, now minus 5 is what kind of root? Minus 5 comes from an odd factor, right? So the sign across that will change. What did I tell you? Sign across that will change. So on the right hand side, if it is positive, here it will be negative. And 3 is what kind of root? It is even root. Are you getting it? So on the either side of 3, it will be same. The function will have the same sign. That is what we have learned in the previous thing. What was minus 2 over here? Minus 2, right? On the either side of minus 2, the function was positive because it is a even powered factor, x plus 2 whole square, isn't it? Okay. Now, coming back to this. Okay, what is 11 by 3? 11 by 3 is an even factor. So here, if it is positive, that means over here also it will be positive. The sign, across the even powered factors will always be same. Are you getting it? I hope this is clear. So let me write this, these pointers. Okay. So how the graph will be? Let me mention the graph as well. So the graph will be after minus 5. This is positive, right? And at 3, touching, and then going up. Are you getting it? So it will be something sort of this. Okay, because it is always positive. Now, what is my answer to this? Answer is less than or equal to 0, right? So how do I write my answer? X less than minus 5, because at minus 5 also it is 0, isn't it? Or x is equal to 3, or x is equal to 11 by 3, because x is less than equal to 0. Okay, so x less than equal to minus 5 and this. So how do I write this in terms of interval? Yeah, minus infinity, minus 5, and 5 being inclusive. So I'll write square brackets, okay, union, curly brackets, 3 and 11 by 3. Individual values. So this bracket gives us individual values. Okay. So what it means basically, 3 and 11 by 3, okay, are also the part of the solution. I hope it is clear to you now, right? So let me give this as a note. What is the learning from here? We can say when a root occurs odd number of times, okay, when a root occurs odd number of times, like what we have seen over here, x to the power 7, right? This is odd, this is even, and this is even. Okay, so in that sense, when a root occurs odd number of times, all right, the sign changes, across the roots, so this is the first thing. Okay, next, for a root that occurs even number of times, the sign across the roots, or instead of roots, it would be appropriate if I write just root, remains the same. Okay, as simple as that. Let's take one more question, then it will be even more clear to you. All right. Now, let me take x square times x plus 3 whole cube x minus 4 less than equal to 0. All right. Now, what is the first thing we have learned? To find the roots corresponding to all these factors. So we get, if I equate x square equal to 0, I get x equal to 0. Then from the second root, I get minus 3. And then I get x equal to 4. Yes or no? Second step, right? What are these roots? Right, corresponding to what factors? Are they even powered? They correspond to even powered factors or odd powered factors. So x equal to 0 is my even powered factors. Right, minus 3 goes for odd powered factor. 4 is for odd powered factor. Yes or no? Next step, put them on the number line. So how do they look on a number line? We have minus 3, we have 0, and we have 4. Okay, this is what we have here. Next. Now, take 5. Okay, so if I plug in 5 over here, now you check here, I'm checking here, 5. Okay, you can take any number between all these things. Okay, I'm just taking 5 greater than 4. So 5 square, positive, right? 5 plus 3 to the power 3, again positive. 5 minus 4 is 1, which is again positive. So positive times positive times positive is again always positive. So here the graph is positive. Now, for the remaining signs, I have to check what is this root 4. It belongs to odd factor, right? So what kind of root is this? Odd root, because the power over here is 1. So sign will change. This will become minus. What is 0? 0 is even, so sign will remain same. Okay. What is minus 3? Odd, so sign will again change. Getting it? So now, what is my answer? At 0, is it defined? Yes, it is defined at 0 as well. Okay. So my answer should be finally x greater than minus 3. It should be negative, right? And less than 4. Equal to, obviously. Getting it? If equal to sign would not be there, then how you'll write the answer? X is greater than, yes. If equal to is not there. So let me take that case as well. If you have x square, x plus 3 whole cube, x minus 4 is just less than 0. Then in that case, what would have been the answer? In that case, x will belong to, from where to where? Minus 3 to 0, union 0 to 4. Because 4 is not inclusive, isn't it? Yes. So I hope this is clear to you. Let's try one more question that will be more clear. Next. The next question is x minus 5 to the power 5, x minus 2 to the power 1, x plus 1 to the power 2, x minus 3 to the power 8 is greater than 0. Okay. Now, pause it and give it a try. Now, let me solve this. First thing is to find the roots. And the roots what we have over here is 5, 2, minus 1, and 3. Right? Now, corresponding to all these roots, write the nature of the factors, whether they are even or odd. So 5 is odd because the power is 5, odd number. 2 is also odd. Minus 1 is even powered factor. And 3 is also even. Okay. Next thing is to put them on the number line. Now, on the number line, how do I put it? Minus 1. Then we have 2. Then we have 3. And then we have 5. Okay, so this is the number line. Now take any number. Let's take 6. So if I take x equal to 6, right, what will happen to the first factor? 6 minus 5, positive. Then you have 6 minus 2 to the power 1, positive. 6 plus 1 to the power 2, positive. And 6 minus 3 to the power 8 is again positive, right? So positive times positive times positive. This will give you a positive answer. So here the function is positive. Now phi is what kind of root? It's an odd root, isn't it? So sign will change. Here it will become negative. Getting it? Yes. And then 3. 3 is what kind of root? Even. So sign will remain same. 2. 2 is an odd root. So sign will change. What is minus 1? Even. So sign will remain same. Right? Now they have asked where the function is greater than 0. So how do I write my final answer? X belongs to, yes. Okay. So minus 1 is not inclusive, right? So how should I write it? I should rather write minus 1 to 2 interval union minus infinity to minus 1 union and then greater than 5. So 5 to infinity. Getting it? Because minus 1 is not inclusive, that's the reason we are writing like this. Otherwise, we should have written minus infinity to 2 if this would have been equal to. Okay, if this would have been equal to, I should have written my answer as minus infinity to positive 2. This entire thing. Is it clear? Perfect. Okay. So I think this is enough. Now let's move on to the new topic, which is asymptotes. Asymptotes. Now let's understand what are asymptotes. Okay. Let's say, for example, if I have a function something sort of this, and this is going this way. This is my y equal to some function f of x. All right. And this is x equal to 5. And let's say this is y equal to 1, something like that. All right. And this is going like this. Like this. All right. And it appears to touch. Right. So how do I define asymptote? Asymptotes are nothing but the line about which the function appears to touch it. Right. As you can see, when we are approaching 5, right, from left hand side, where is it approaching? Going to infinity. Right. Similarly, when x is approaching infinity, where is this graph approaching? Approaching towards y equal to 1. Will it touch y equal to 1 line? No. Okay. So what do we say over here is this x equal to 5 is called as my vertical asymptote. Okay. And then y equal to 1 is called as my horizontal asymptote. Horizontal asymptote. All right. So the equation of any vertical asymptote will look something in general x equal to a, and the equation in general for any horizontal asymptote will look like y equal to a, some constant. Okay. So basically these lines, right, the graph appears to touch, right? It is tending to touch. It is not touching it. So let me write it over here. What it means. Basically, these are lines. What are asymptotes? Asymptotes are the lines that the function, okay, that the function tends to meet at infinity. Okay, it tends to meet at infinity. See, here also it is going towards infinity. Here also it is going towards infinity. Here also, and here also. Are you getting it? Right. So what we can say over here is when x is approaching positive 5, right, 5 plus. So whereas y going, that means on the right hand side, when x is approaching 5, my y is going towards positive infinity. Yes or no? This is y value. And when x is approaching pi minus, that means something lesser than pi, slightly lesser than pi, whereas y is going towards negative infinity. Yes or no? Okay. So this is basically my horizontal thing. Okay. Now, can I simply say when x is approaching positive infinity, where is y approaching? Y value, the graph is approaching 1, isn't it? And when x is approaching minus infinity, where is y going? Y is still going 1 from here. So I hope it is clear to you. The graph, it looks something sort of this. Here it is going this way when x is approaching infinity and minus infinity. Okay, so what is an asymptote? It's a line that the function tends to meet at infinity, right? So this graph is going like this. So it tends to meet at the infinity. Yes or no? Perfect. Now, how do we find the equation of these asymptotes? Let's take an example and then learn how to exactly find them. Okay. So let me take an example or rather a question. Let's suppose we have any function, a rational function, which is defined as numerator over denominator, some polynomial functions, right? So what kind of function is this? Basically a rational function, right? So it's a rational function. Now, we don't define, asymptotes for these type of functions like polynomial function where we have y equal to x square, right? So it's a parabola. We don't define asymptotes for this. Asymptotes for polynomial functions. Are you getting it? So when we have rational function, then only we define it. So let me take an example over here. Let's suppose you have y equal to x square plus 4x plus 3 divided by x square plus 5x plus 6. Okay. Now, how do we find horizontal asymptote? And how do I find vertical asymptote? This is what the question is. Okay. So now what we do over here is solution. The very first thing is factorize it and cancel out whatever are the common terms. So when I factorize the numerator, you see two numbers whose sum is 4 and product is 3 is 1 and 3. So I can write it as x plus 1 times x plus 3. Yes or no? Divided by, right? Two numbers whose sum is 5 and the product is 6. So 2 and 3, x plus 2 times x plus 3. Now, simplify it. Now, when we simplify, I can cancel out the common factors, x plus 3 and x plus 3. Okay. So in step 2, I can write cancel the common terms. Always. Always. The first thing is factorize and then cancel the common terms. Once you cancel the common terms, what is your y? Isn't it x plus 1, right? Divided by x plus 2. It is, isn't it? Now, in order to find the vertical asymptote, what did I discuss over here? In general, how the vertical asymptote will look like? X equal to a, right? Any sort of vertical asymptote will have an equation x equal to something, right? Now, from where do you get x equal to something? When you equate the denominator to 0. Just equate the denominator to 0 for vertical asymptote. Therefore, x equal to minus 2, right? This is my vertical asymptote equation. Are you getting it? Right? Now, let's quickly discuss about how to find the horizontal asymptote. How to find horizontal asymptote. Okay. So in general, what is the equation? Y equal to a. This is in general the equation of any horizontal asymptote. This is what we know. Okay. So I'm giving you one theory for this, which you can use, right? Because we have discussed that horizontal asymptote, there is one more which is oblique asymptotes. That is not required over here. Okay, for calculus part, that's a different thing. We are going to deal with only horizontal asymptote and vertical asymptotes. So in general, if I have any function, a rational function y equal to some numerator by denominator, okay, in such a form that it is ax to the power n plus dot dot dot, a polynomial function, and here we have bx to the power d dot dot dot. Because we know that how does a polynomial function look like? Ax to the power n plus, it looks something sort of this. An x power n plus an minus 1 x power n minus 1, and so on and so forth. Last term is 0. Okay, so in that way, I have written this. Okay, now there are three different cases. Okay, so let's talk about the cases. Case 1, right? Now, what is the leading term here? Leading term is this. So let me mention these things. This is called as my leading term. Okay, and what is the leading term in the denominator? Bx to the power d. All right. Now, case 1 is when we have the powers equal, right? That means the degree, this is called as the degree. What is n? N is called as the degree of the numerator, and d is called as the degree of the leading term of denominator. When the degree of numerator and denominator is equal, then what is my y? Basically, the horizontal asymptote, the coefficient of x to the power n divided by coefficient of x to the power d. Okay, which is nothing but a by b. Is it clear? Next, case 2. Case 2 says if n is greater than or less than d, right? The degree of numerator is less than the degree of the denominator. Then what happens? Y is equal to 0. Okay, this is my horizontal asymptote, the equation of y. Okay, next, the last case is case 3. If n is greater than d. Okay, so here the horizontal asymptote does not exist. Okay, or rather we get a slant or an oblique asymptote exists, which is not the interest of calculus. Okay, we will not be dealing with these type of scenarios where n is greater than d. So I hope it is clear to you. Right, now coming back to our previous question, which was this: I have to find my horizontal asymptote for y equal to x plus 1 divided by x plus 2. Okay, now what is the degree of this x plus 1? This is 1 and this is 1. Right, so here I can clearly say that n is equal to d. Right, so what is the coefficient of x? 1. Here also it is 1. So rather, what should I write? I should simply write it is 1 by 1, which is equal to 1. So y equal to 1 is my horizontal asymptote. Okay, since the coefficient of x is 1, here the powers are equal. Then divide the coefficients. Coefficient of numerator divided by coefficient of this. Let's quickly take one question based on this. Then it will be more clear to you. Let's suppose we have y equal to x minus 8 times 3x minus 9 over 7x square plus 49x. Are you getting it? Now, question says find the horizontal asymptote and the vertical asymptote. So I'm writing it down over here. First, let's start with the vertical asymptote. Okay. Now, okay, first thing is to factorize it. So can I clearly say my y over here is basically 3x square, isn't it? So it becomes 3x square minus 33x plus 72. If you simplify these two, multiplication over 7x square, right, plus 49x. Are you getting it? Now check the power of numerator, leading term of the numerator and the denominator is same, right? So what will be my horizontal asymptote? My horizontal asymptote would be how much? Y equal to just divide by the coefficients, coefficient of x square and coefficient of x square. This is my horizontal asymptote. For vertical asymptote, we have to factorize it. Okay, and cancel out the common factors. So once we factorize this, what do we get? We already have x minus 8 and we get 3x minus 9. From the denominator, I can take 7x common and I'll get x plus 7. Are you getting it? So now, if nothing can be cancelled out, just equate the denominator to 0. So what do we get? X equal to 0, or we get x equal to -7. So this is my vertical asymptote. Are you getting it? Yes. So that's all in this lecture. We'll continue in the next lecture with horizontal and